Let's take a look at slope. So we've looked at some slope before, and we're going to go a little more in depth today. So by the end of this lesson, you should be able to determine the slope in new ways using both tables of values and given points. And you'll also be able to draw new points on a graph if you already have one and the slope. Let's go down and remind ourselves of what we've seen before. So we've seen the formula rise over run, and we use the letter m to represent slope. So that's what we start off with. And we looked at that in various contexts. When we were given a graph, we were able to count, how far to the right did we go, how far up did we go, and use that to figure out the slope value of that particular graph. So let's continue on, and let's see another version of the slope formula. So another way to write out the slope formula is if you're given 2 points. They're given 2 points, maybe one's over here, one's over here. We don't know. They could be any 2 points on the graph of any line. But in general, what we can do is the distance across, so the run and the distance up, we can represent that in a new way. So the rise here, that's the same as the difference in our 2 y values. And we sort of did talk about that before. And the run going across, well, that is just the difference from your one x value, your starting point, to the other x value going across. And so what we can say is we can say this is the change in the x value, or x values. All right. We can write this down in a new way, though. So we actually have notation. So instead of writing change in y values, change in x values, this little triangle is actually the Greek letter delta, and it represents basically the words change in. So when I write delta y, that just means change in y. So delta represents change in. So again, we like to make short forms in math, and this is one of those short forms. So the change in y over the change in x. So this is the first new way of writing the formula. Right? We also have an additional new way of writing it, which is just based off of this. So what do we mean by the change in y? Well, more specifically, we can write it out as the y value of our 1 point. We'll say the 0.2, the one at the top, subtract the y value of the other point. That would be the change in the y values. You divide that by the change in your x values, which again, going in the same order, the x value of the 1 point, subtract the x value of the other point. And so this is another important way to think of the slope, and another formula we can think of it. All right, so those are slopes. We're just continuing to expand upon rise over run, seeing it in new ways. So using that, let's determine the slope of a line that goes through the points 1, 2, and 5, 4. Before, you might have graphed it. Now, we don't even need to graph it. We can right away use this formula, y2 minus y1 over x2 minus x1. And off to the side, let's write down our 2 points. So 5, 4, and 1, 2. I will call this point 1, and I will call this point 2. So then when we're substituting in our values here, y2. So when we see y2, we're looking at the y value of 0.2, so the 4. And that goes here. Then we're next looking at y1. Well, y1 is then just the y value of the first point, so the 2. And so that will be subtracted like that. Then let's continue. I'm just going to continue using different colors. x2, so that's the x value of 0.2. So the 5 there. We're going to do 5 minus. And the last part is x1, so the x value of 0.1, which is this one here. 5 minus 1. And so when we do that, 4 minus 2 is going to give you 2. 5 minus 1 is going to give you 4. So you have 2 over 4. And since it's a fraction, you can always, if you can, reduce it if possible. So 1 over 2 is the same as, 2 over 4 is the same as 1 over 2. Got ahead of myself there. All right. So here's how we can solve it without a graph now. Let's continue and look at some other important things. So sometimes you might be given a point and you want to draw the line of a graph, but you just have, let's say, the slope. So how can you, with a single point and the slope, figure out what your graph is going to look like? So let's look at some possible points for a second value of a point. So what does slope tell us? If we have a slope of 1 over 2, remember that's rise, and that's 2 is run. So we could just draw that onto our graph. So let's start with the left graph here. You could go up 1 and go across 2. And if you do that, well, where we just arrived, that must be another point on that particular line. So we can label that as coordinate B. Okay. But that's not the only point on our line. There's many points on our line. So what else could we do? Well, I'll do that on the right side here. You could go up 1, cross 2, and you could just keep repeating this. Up 1, cross 2, and that new thing there would also be a point. And this pattern doesn't just go forward. You could also go backwards. So what's backwards? Well, down 1 and back 2. And so something like over there would also be another possible point. And those would all lie on, if we draw the line, you could draw a line something like this in both cases. If you have a nice ruler, you can make it nice and straight on your sheet. All right, so there we have it. Given a point and the slope, we can nicely and efficiently find another point on that line. All right. What if we weren't given the graph though, like we just were? How would we figure out the other point? This is where we have to use, again, the same sort of ideas, rise over run, but think of it in terms of coordinates. So we're starting off with the point 4, 7. And we know we have a slope, I'll write it over here, -5 over 3. So again, remember, the top is our rise. In this case, if it's negative, that means we're going down. And on the bottom is our run. And what does slope tell us? It tells us how our x and y values are changing. So I'll write that as well. Change in y on the top. Change in x on the bottom. So to find a new point, we can just directly use this change in value, we'll call it, and apply that to the coordinates we already have. So right now, we have an x value of 4. Well, we know the slope says we change in y by -5. So we can do 4 minus 5. And what is that going to give you? -1. So that would be a possible new x value. Oh, sorry. We just completely messed up there. I said change in y. So that should be with the 7. So let's go back through that. So 7, change in y by 5. So 7 minus 5. which will give you 2. So that would be a totally new y value. All right, and the 4, well, that's going to be changed in the x value. So we use the run part. So you'd use 4, and you're going to add 3 this time because it's positive there. And you'll get something like 7. And so that leads to a new point, which would be 7, 2. So you're just directly applying that rise and your run. And again, just be careful about which is which changes the y value, which changes the x value. As you saw, it's easy to accidentally make a mistake like that. All right. Now let's think back to tables of values. So we've seen some tables of values previously. And what we had said previously is that when we have a table of values, we had looked to see, is there some sort of pattern in the way it's changing as you go up the table or down the table. And in this case, if you look at the left side, we have something like +3 each time. And if you look at the right side, so the y values usually, which we also call the first differences, these numbers, you're adding to each time. And what we had said is that if the first differences are constant, then we have a line. And if we have a line, that means that line's going to have some sort of slope value. And so it'd be nice to be able to know what is that slope, how steep is that line. So let's go ahead and actually take a look at that. So how do we do that? Well, we're actually going to use these change in values that we have drawn or written on our table, and we're just going to use those directly. Because essentially, those are going to be the parts that create the slope. So for the height, we're just going to treat that as our y, and for the day, we're going to treat that as our x. So usually the first column is x, second column is y, because the second column, that's kind of our dependent variable, the thing that's changing based on the independent variable. And again, this value here, the first difference, this is our change in y. So when we're writing out the slope, we know it's delta y, which is change in y, over delta x. So if we know our change in y, we can just put that into our slope value. What's the change in x going to be? Well, that's the other side of the table of values. So the +3, that's our change in x. And so when we're looking at our slope, delta x, or change in x, write it as that number from the left-hand side of the table. And so 2 over 3, that is the value of the slope. Okay, let's take a look at some other graphs looking at these differences and then determining the slope based off of that. So again, let's see what's happening in the x column. So we're adding 1 each time. And then let's see what's happening in the y column. We're subtracting 3 each time. And so then if we're doing the slope, it's the change in the y column, so the -3, over the change in the x column, which is just 1. Or you could just write that as -3, because divide by 1 doesn't really mean anything. So that's a look at the slope of that thing. And we can tell it's linear because all of the numbers are constant. along each of the two sides. All right, let's take a look at another one. Double check, first of all, the change in the values. So we're going up by 3 in our first column. The second column, 25 to 16, well, you have to subtract 9. 16 to 9, you're subtracting 7. 9 to 4, you're subtracting 5. So if you were to try to do the slope now, you'd see we'd have different change in y values. Well, that would mean you wouldn't have a constant slope. And so this actually means this is not a line. Since those first differences are not all equal. Okay. And so that's a look at how we can make use of a table of values to figure out the slope, and also just double checking if something's aligned. And then also just being able to use alternate forms such as y2 minus y1 over x2 minus x1 to determine the slope of a line.